Now going to talk about order of operations. Order of operations means if there are no grouping symbols, or when there are, what order do we perform the arithmetic operations of addition, subtraction, multiplication, division, and we're also going to include exponents. It's a little saying that people often use to help them recall the order of operations, and you've probably heard it, but I'm going to write it here for you. Please excuse my dear Aunt Sally. I'm going to write it layered like this so that we can think about what that means. The please excuse stands for parenthesis and exponents. We do these first, starting with the most inside ones and working to the most outside ones. Then we do multiplication and division. They're on the same level. This is a part that often people don't have, is that multiplication and division are on the same level from left to right. That means if division comes first, we do it first. If multiplication comes first, we do it first. And then after all of that's done, the last thing we do is the adding and the subtracting, and we do that from left to right as well. So we want to look at some examples of these. Okay, let's start with a relatively straightforward one. 5 plus 2 times 3. Now as I write each step, I'm going to copy the parts that I don't work on so that at every point of working this out, I will have a statement that is correct. Now this is called an expression because there's no equal sign. So this is an expression, and I am simplifying it. Simplifying it using order of operations. So basically, we're going to simplify expressions, and later on we'll be solving equations. So here we're simplifying this expression. I see in it addition and multiplication. Since multiplication is at a higher level, I'm going to do this multiplication first, and I'm just going to copy the 5. I can write it neat enough. 5 plus, what's 2 times 3? 6. So now I have done the first operation, the multiplication. I now can do the second one, which is to add 5 and 6 and get my answer, which is 11. Okay. Let's try another one. 8 minus 2 times 3. Now we can think of this in two ways. So let me write it twice. And whichever way is easier for you to think about is the way you should think of doing it. We've got two operations here, subtraction and multiplication. So multiplication's higher, so we're going to do that first. If you want to, you can think of this as 8 minus, and what's 2 times 3? 6. Okay. The other possibility is you can think of this as negative 2 times positive 3, so all I'll be copying is the 8. When I multiply a negative number times a positive number, I get a negative number. So negative 2 times 3 is negative 6. So I've arrived at the same point. You can think of the subtraction line or the negative sign as a negative or subtraction, either way. The only thing is, if you think of it as a negative sign, if this answer had turned out to be positive, you would have to write the plus sign in. Okay, 8 minus 6 is 2, so my answer is 2. Okay, so let me give you an example. Try. Five minus 4 times 3. So you try that one. Why don't you pause this, work it out, and then when you're done, start it up, and I will work it, and you can see if you have done it correctly. Okay, hopefully you have done it correctly. Hopefully you did the multiplication first, and you either did 5 minus 12, or you multiplied negative 4 and 3 and got 5 negative 12. Either way, it would look the same, 5 and a minus sign and a 12. Now that's a positive 5 minus a 12, so when I add them, I get negative 7. Their signs are different. 12 appears in absolute value to be bigger, so my sign is negative. Okay, let's go on to the next level of operations. And try 24 divided by 3 times 4. Now multiplication and division are on the same level. We do the one that is on the left or the one that comes first. So in this case, the division is first, so I'm going to do the division first. 24 divided by 3 is 8. I'm going to copy the times 4 and then do that next step, which gives me 32. Okay, let's do another example. 4 times 6 divided by 12. Okay, which one is first here? The multiplication is first, so I'm going to do the multiplication first. 4 times 6 is 24, and then I'm going to divide by 12. 24 divided by 12 is 2. So my answer is 2. Sometimes instead of seeing a division sign written this way, you will see it written with a slash. It's often the way it will be done in your calculator, will be with a slash. So 6 divided by 3 times 2. That's in order from left to right. So I'm going to do the 6 divided by 3 first, which is 2. And 2 multiplied by 2 is 4. So my answer is indeed 4. Okay, if you wanted to do the multiplication first, you would have to have put it in parentheses. 6 divided by 3 times 2. So I have two operations here. I have a divide and I have a times. But remember the please from the please excuse. Parentheses come first. So I have to do what's inside these parentheses first. 3 times 2, which is 6. 6 is just a plain number, so I don't really need the parentheses. It's not wrong to write them. So they're optional. 6 divided by 6 is 1. So it depends, again, which one I'm doing first. If there's no grouping symbols, I assume that I am going to do whichever one comes first. Okay, let's try combining these. What about 12 divided by 2 minus 3 times 9? Okay, let's think about the order of operations. The order of operations says multiplication and division, left to right. So which is on the left? The division is on the left, so I'm going to do it first. 12 divided by 2 is 6. And then next, I'm going to do the multiplication. So 3 times 9 is 27, or if you want to think of it as negative 3 times 9, that would be negative 27. Seeing that there is no interference in between doing this portion and this portion, I could have actually done them together and done the 12 divided by 2 is 6, minus, and the 3 times 9 is 27. To get more comfortable with this order of operations, you may choose to do that. 6 minus 27 is negative 21. So my answer is negative 21. Okay. Any of these that you spot as I write them, and you think you know how to do it already, would be a good idea to stop playing and try it yourself, and then watch how I've worked it out to see if your understanding of it was correct. So this next one is 6 minus 4, parentheses, 2 minus 9, and close the parentheses. Okay, so order of operations tells us to do which one first. Remember, please excuse my dear Aunt Sally. Parentheses are at the top, so I need to do those first. 6 minus 4. And inside the parentheses I have 2 minus 9, which is a negative 7. They are different signs, so I get a negative 7. Now, can I erase those parentheses because there's a single number inside? Well, I've got to remember I'm using these parentheses in this case also to remind me that negative 4 is getting multiplied by negative 7. So I can't just erase these. If I do, it'll look like negative 4 minus 7, and I don't want that. I'm going to go ahead and put a red dot. Usually I use red to indicate things that are typically invisible, but we write them in so that we can see them and be reminded they are there. So now I have left subtraction here and a multiplication here. Multiplication comes before subtraction, so I need to do the multiplication first. I could do 6 minus 4 times negative 7, which would be negative 28. Or I could do the whole thing together and say 6 negative 4 times negative 7 is plus 28. But remember, if I did it this way, the negative would hop on top of the other negative. So either way, I end up with 6 plus 28. And 6 plus 28 is 34. So my answer to this one is 34. Okay, I want to mention a little bit about these exponents over here that we have in our little saying for the order of operations. Remember, an exponent is not multiplication by itself, it's repeated multiplication. So for example, if I have 2 raised to the 3rd power, and if you have a calculator, there are 2 buttons that are usually used for this: the x raised to the y, or the y raised to the x, or what we call the caret key. So you'll probably have one of those 3 buttons. If you have a scientific calculator, you probably have one of the first 2, although more and more of the newer calculators are starting to use the caret. The caret is also on the graphing calculator. Okay, but let's do this one by hand. 2 to the 3 means that 2 is going to get multiplied 3 times. So that's 2 times 2, which is 4, times 2, which is 8. Okay. What about 3 to the 2? That means 3 times 3, which is 9. Okay. What about 5 to the 3? That would be 5 times 5 times 5, which would be 5 times 5 is 25, times 5 again is 125. Not to be confused with 5 times 3. Okay, let's try a 4th power. What is 3 to the 4th power? 3 times 3 times 3 times 3. We know that multiplication is what we call commutative and associative. So rather than just saying 3 times 3 is 9, 9 times 3 is 27, and what's 27 times 3? You could work that out. We can say, let's do these 2. 3 times 3 is 9. And that 3 times 3 is 9, so 9 times 9 is 81. Okay, or you could do what I said a minute ago. 3 times 3 is 9. 9 times 3 is 27. And 27 times 3 is 81. Let's put a negative number in here. Negative 3 to the 4th power. And notice that the 4 is on the parenthesis. That means that the parenthesis and everything inside the parenthesis must get multiplied together 4 times. Well, negative 3 times a negative 3 is a positive 9. Then I'm going to have a positive 9 times a negative 3, which is a negative 27. Then I'll have a negative 27 times a negative 3. A negative times a negative is a positive 81. Now, if I wanted that negative 3 to be repeated 4 times, it's required to use the parentheses. If I don't use the parentheses, what is that 4 on top of? It's on top of the 3. It's not on top of the negative. It's just on top of the 3, so only the 3 is going to get repeated. The 3 is going to get repeated 4 times, but there's still only one negative sitting out in the front. So when I multiply this, I'm going to have negative 3 times 3 times 3 times 3. So that is going to be negative 81. In general, when you multiply numbers together, if you have an odd number of negatives multiplied gives us a negative. And an even number of negatives multiplied is going to give us a positive. So for example, we'll just use 1. Negative 1 times negative 1 times positive 1 times positive 1 times positive 1 times negative 1 times negative 1. I have 4 negatives. That's an even number. So my answer is going to be positive 1. Negative 1, negative 1, positive 1, negative 1, negative 1, negative 1, positive 1, positive 1. How many negatives do I have here? 5 negatives, which is an odd number. So my answer is going to be negative 1. Okay, let's look at another order of operation problem. Let's look at negative 6 plus, open parenthesis, negative 2 plus 4, close parenthesis, raised to the third power. Okay, so let's think about the order of operations again. So please excuse my dear Aunt Sally. And we have parentheses and exponents. Remember, they're top. And we start on the inside out. Well, here we have the parenthesis inside of the exponent. So we're going to do the parenthesis first. Negative 2 plus 4 is 2. So we need to do 2 to the third power. Because now we have an addition and an exponent left. So exponent is higher. What is 2 to the third power? Well, over here on my scratch paper, if I can't remember what 2 to the third is, I can work it out. 2 times 2 is 4, and 4 times 2 is 8. And now I have the addition left. Negative 6 plus 8 is 2. Okay, let's do an example with the other way. Negative 3 times 4 plus 2 times 3 squared minus 6. I again have an exponent and a parenthesis, but this exponent is inside the parenthesis. You could actually say I'm doing the parenthesis first, or you could say I'm starting on the inside where the exponent is. You can look at it either way. So I'm doing the exponent, which remember 3 squared is 3 times 3. So that's really 9 minus 6. Now next I have a parenthesis. So 9 minus 6 is 3. Next I have the multiplication step, left to right, so negative 3 times 2 is negative 6, and if you want to write it as a separate step, you can write the 2 times 3, or you could just jump to this step. Negative 3 times 2 is negative 6, and positive 2 times positive 3 is positive 6. So whether you write this step or not, you will get to this step, negative 6 plus 6. And what is negative 6 plus 6? 0. So my answer to that problem is indeed 0. Okay, let's try this one. Again, think you know how to do it. You might just stop the recording and work on it, and then start it up again. In fact, you could fast forward and see you got the same answer. Okay, so this one is open parentheses 3 minus 6, close parentheses, squared, or to the second power, minus 3, open parenthesis, 5 minus 2, close parenthesis, to the exponent third power. We call that cubed. So the second power is squared to the third power is called cubed. Okay, so in this case we need to do what's inside these parentheses first. So 3 minus 6 is negative 3. Again, you could do this in two separate steps, or I can do both of these together because they're not interfering with each other. 5 minus 2 is 3. Notice this is in parentheses, so negative 3 squared is negative 3 times negative 3, which is a positive 9. Over here we have just a plain 3 in parentheses, so that's 3 times 3 times 3, and I really didn't need those parentheses, but I get 27. Aha, now I come back over here and I see I either need to put a parenthesis or I can replace it with a dot if I would like. I have to put something there, otherwise it would look like the number 327. And I can't put a plus sign saying, oh, well, 27 is a positive number, because then that will look like 3 plus 27. So I'm best off probably just to keep the parenthesis. 9 minus, what's 3 times 27? 3 times 7 is 21. 3 times 2 is 6. Plus 2 is 8. So that's going to be 9 minus 81. And then when I subtract, what am I going to get? I'm subtracting backwards here. I'm doing 81 minus 9. Is that right? 11 minus 9 is 2. Yeah, except I had switched my signs up here, so really the top one was negative and the bottom one was positive. So this should really be a negative 72. So when I went to work out my subtraction by hand, I subtracted backwards to find out what my negative answer would be. Okay, now remember, fractions are division. So let's look at an example of that before we stop. 2 minus 8 over 1 plus 2. What do I have to do first when I do this fraction? Well, whenever you have addition or subtraction, in a fraction, there's parentheses around the entire numerator and around the entire denominator. Actually, it's not only when there's plus or minus, it's really what? In a fraction, there is a parenthesis around the entire numerator and around the denominator. It's going to bother us the most when there's addition and subtraction. So I'm going to put in the invisible parentheses around the numerator and the denominator to help me realize what I need to do. So I need to do what's in the numerator first. 2 minus 8 is negative 6, and 1 plus 2 is 3, and negative 6 divided by a positive 3 is a negative 2. What if I was going to put this in my calculator? How would I put it in my calculator? I would have to put it in parentheses 2 minus 8 divided by 1 plus 2. The parentheses are necessary. It's two pairs, so parentheses are necessary. So in this case, I have to be careful with that. That's the order of operations, and while you only have 3 or 4 questions in your homework on that, as a review in case you needed that much. In the next section, I will look at evaluating expressions. We will look at distribution and putting like terms together and so forth. And in the last session of Homework 1, we'll look at equations.